Okay, 2.1 is going to be on graphs of equations. And what we're going to talk about today is kind of what happens to the shape of a graph depending on what you are doing to the x. Okay, so like if it's just an x, it's going to be a straight line. If it's an x squared, that's going to give it a different shape. If it's an x cubed, that's going to give it a different shape. We're going to talk about that today. Okay, so let's look at number 1, which is y equals 3/2 x plus 1, and it's wanting you to graph the equation by plotting points. Okay, now I'm going to do this by hand, and then I'll show you how much easier it is to do it in the calculator and much less room for a mistake. Okay, now we're going to be plotting points. We're going to make ourselves this little XY chart. And we're going to choose numbers to plug in for this X. And when we plug that number in for X, it's going to give us the Y that will go with it. Okay, so if my first number I always choose to plug in for X is a 0 because usually it just makes the math easier. So if I replace the X in this equation with a 0, I have Y equals 3/2 times 0 plus 1. 3/2 times 0 is 0. That's why I like to plug in 0, right? Because it makes that math easier. Because anything times 0 is just 0. Bring down the plus 1. So Y equals 0 plus 1 is 1. So when you plugged in 0 for X, did the math, it gave you a 1 for the Y. So what you're coming up with here are points on this graph. And if you did print these off, and on a lot of graphs, you'll notice that these hash marks go by 2s, right? That one will be 2, that will be 4. So it's hard to graph on these by hand. So when you're in math lab, remember we talked about this on Monday, either in the yellow rectangle up here or down in the bottom down here, it's going to tell you where you are on the graph when you're plotting points. So just make sure before you plot a point that you're hovering over the point that you're actually trying to plot. So the point 0, 1, if your X is 0, you don't go left or right at all. If your Y is positive 1, you'll go up 1. So there's where 0, 1 would be. Now, if you'll notice, there's no way I can tell, even if this is a simple shape such as a line, which way it's going. It has to have another point to connect and draw the line. So you do have to have another point. And it's kind of tricky if the number that's hooked onto the X is a fraction. You don't want to get fraction answers for your Y. The way that you are going to avoid doing that is whatever your fraction is, plug in this number. And you'll see why. So if I do that, I have Y equals, let's see, since my denominator is a 2, that's what I'm choosing to plug in for the X. Because here's what happens. If I plug a 2 in here, I have 3/2 times 2 plus 1. When I do this multiplication, I have a 2 in the top and a 2 in the bottom, so they just cancel each other. That's why you want to use the 2s. So then all I'm left with is Y equals, all that's left out of this mess is just that 3, drop down to plus 1. So you're just left with Y equals 4. So if I plugged in a 2 for the X, it gave me a 4 for the Y. There's my other point that I can plot. So to the right 2, up 4. Right 2, up 4. There's that point. Once you connect the 2 points, it will draw the line for you. Okay, when you are graphing in Math Lab, remember the very first thing you're going to have to do is come over here to the toolbox, and there's several different tools to choose from. All these different tools. Before you do anything, you're going to have to show what the graph is going to look like. If you know it's going to be a line, you're going to have to tell Math Lab that. Now, here's how you're going to know every time, even if you aren't comfortable with graphing or haven't done it on a graphing calculator before. I'm going to do this same problem in the graphing calculator. Now, my equation says y equals 3/2 x plus 1. You really like when it says y equals, because when you're graphing on the graphing calculator, that's what you're going to use, is the y equals button. So that's where you're going to hit first. If you have stuff in there like I do, just clear it out, hit the clear button. To type in 3/2 x, to type in a fraction, you just do whatever the top number is, then hit divided by the bottom number. So 3 divided by 2 will give you this fraction. Your x button is this one right here. So 3/2 x plus 1. So just plus 1. Now, before I do anything else, I'm just going to hit my graph button, which is at the top right. That's what's going to show you the shape of the graph. So when you're in Math Lab, that's what's telling you which tool to pick out of that toolbox that's on the right. Or sometimes it's on the bottom. Okay, so that's what tells you to tell it what shape. Now, here's the good thing about this calculator. Hit the second button. And then hit the graph button again. Look what it does for you. It makes this for you. Your XY chart will be there for you, which means 90% of this problem was spent doing this work. You don't ever have to do that ever again, right? If you've got the tool, let's use it. So again, to get there, you hit the second button, and then you hit the graph button again. It's going to give you your XY table. Then you're just going in and picking points out of it. You can pick any of the points you want. It doesn't matter. I would steer clear of anything that has a decimal though, right? It's just too hard to plot that. So you want to do like we did 0, 1, 2, 4. You're going to do this, -2, -2. Anything that's not a decimal, just pick it and graph it. Okay, so this is what we're going to do from here on out, is use our graphing calculator. Let's look at number 2. 4y plus 2x equals -8. Now, unfortunately, this one's not set up like we like it. That last one started off with y equals, which means we could go straight to this y equals button. But in order to go to the y equals button, the y has to be by itself. That's why in that support lesson that we did on Monday, that's why we practiced doing that, getting the y by itself. Because that's what we're going to have to do on this problem. So get rid of the plus 2x with a minus 2x. So that's going to get rid of the 2x. All I have left over here is the 4y. Drop down my equals. Now, remember, just like on some of the problems on Monday, none of these could not go together, right? That's an x, and that's just a plain number called a constant. So you can't put those together. So you're just dropping these two terms down. So the negative 2x and the minus 8. Divide by 4. Get rid of this 4. So those cancel. Here's my y equals. That's what I'm looking for so that I can go to my calculator. Now, reduce these fractions. And remember how we reduce fractions in the calculator? Now, if you're stuck on this, anytime you're trying to get back to just the home screen, hit this second button and then the button right next to it. That takes you back to the home screen. That's just quitting. So I'm not sure. Sometimes people get this confused if it's 1/2 or 2. So this right here, just type it in exactly like you see it. Negative 2 divided by 4. Hit enter, get a decimal. Then remember, math, enter is what you're going to want to do to reduce fractions. So math, then hit enter twice. That reduces all fractions. So negative 2/4 reduces to negative 1/2. So this right here is negative 1/2 x, negative 8/4. So if I do that division, it gives me negative 2. Here's what you take to your y equals. So again, you just go back to your y equals button, clear it out, and type it in. So negative 1/2 x minus 2. Now remember, when you're typing in a negative, it's this number, this one. The negative and the minus are two separate buttons. So this is negative 1 divided by 2. There's your x button. It's got all those symbols on it. So negative 1/2 x minus 2. So minus now 2. And then graph. Because remember, the first thing you're going to have to tell Math Lab is what shape you're going to draw. It's another line, right? Which since it's just an x, nothing's being done to the x. It's not squared or cubed or anything like that. That's always going to make a line. So I'm going to need 2 points to plot on this line. So I'll just hit, instead of coming up with those points on my own and making that XY chart that takes forever, hit second, graph, and then just choose whichever ones you want, right? Now, remember, you're staying clear of anything over here that has a decimal. But other than that, you're good. I can choose negative 2, negative 1, and 0, negative 2. And I choose to plot those 2 points. Again, tell Math Lab you want to graph a line. And then choose 2 points to plot. So here I am going to plot negative 2, negative 1. So left 2 for the x, down 1 for the y. Left 2, down 1. And then 0, negative 2. So left and right 0, down 2. Left and right 0, down 2. And connect them. All right, number 3. Y equals negative 2x squared. So anytime my equation starts off with that y equals, I like that, right? That means I don't have to do that pre-work to get the y by itself if it's already by itself. So this one says y equals negative 2x squared. this should make a different shape because now the x is being squared. It's not just an x like the first two, it's an x squared, but it is already at y equals. So I don't have to solve, I don't have to get the y by itself because it's already by itself. If your y is by itself, you're going straight to the calculator. So y equals, clear it out. Negative 2x squared. So remember your negative button's down here. Negative 2. Here's your x. Now, the x squared actually has its own personal button. If you'll notice, this right here says x squared. Watch what happens when I push it. It gives me the squared exponent just like I want it. Graph it. Let's see what shape this makes. So it makes a U shape, which is a very common shape. It's called a parabola. It's just that it's upside down. Math Lab that's the first thing that you're going to have to tell Math Lab, right? It's going to have all those tools over there, like we see all the time. The first thing you're going to have to do is come over here and click on this one. Okay, it is upside down, but that's just because it's got a negative in front of it. So I don't need to worry about that. I just need to tell it to do the U shape. Then you're going to go to second, graph again, pick some numbers. Okay, what I like to do when I'm doing that U shape is to look at what makes it mirror itself. If you'll notice, anytime these, see how these y's are the same, and then these y's are the same, that is what's making the U, the one side be the same as the other side. That's what's making the symmetry. So I like to choose the point that's kind of in the middle of those and then on either side. So I'm actually going to plot 3 points on this one just to show you what makes it do that shape. But Math Lab is only going to make you choose 2 after you tell it you want to draw the parabola. So I'm going to plot this one, and this one. So -1, -2, 0, 0. And then +1, -2. So I'm going to plot those 3 points. -1, -2, which means to the left 1 and down 2. 0, 0. Anytime I see that as one of my choices, I'll always plot it because that's the easiest one to plot, right? You don't even have to go anywhere. It's right there in the origin. Then 1, -2, which is to the right 1 and down 2. And again, once you plot just any 2 of those points, it'll draw that parabola for you. I just wanted to show you these 2 points. Since they have the same y, they're lined up in the same spot. That's what makes the U be symmetrical like that. All right, number 4. Y equals x squared plus 3. Y is by itself already, which is what I like to see, right? Because if y is by itself, that means I can just go straight to my calculator, to my y equals, clear it out, type in x squared plus 3. So again, I'm going to hit the x button, and then x squared gives it its own little exponent. And the good thing about that is when you hit this x squared button, it goes up into the exponent, puts the 2, and then comes right back down to where it needs to be. All the other exponents use this button. They don't all have their own fancy buttons. Okay, so if, hang on, I'm going to clear this out and show you what could happen. If your calculator does this, and I did x, go up into my exponent with this up arrow, see how that up thing puts my cursor up into the exponent and the 2, but look where my cursor still is. It's still up in the exponent. This next part that I need to type in is plus 3, which is not up in the exponent. So if for any reason your cursor is still up in the exponent, hit this right arrow. So watch when I hit the right arrow, it puts my cursor back down where I need it to be. And then I type in the plus 3. So again, this is an x squared graph, which means once again, it should make a U shape. So let's graph it so that we'll know to tell MathLab what shape it is. And there it is again, it's a U. So let's get some points. So second graph, there's your table. So again, here's what I like to see happening. These y's being the same. So I'm going to plot these 3 points where I can start to see the mirroring. Okay, so these 3 points are what I'm going to plot. So I'm choosing to plot -1, 4, 0, 3, and +1, 4. So -1, 4 means my x is -1, so I'll go to the left 1, up 4. Left 1, up 1, 2, 3, 4. 0, 3. So my x is 0, so I don't go left or right at all. My y is 3, so I will go up 3. And my last point, +1, +4. So to the right 1 and then up 4 again, right 1, up 4. So you'll see these two have the same y's, so they're lined up. That's what makes it be a U. All right, number 5. This one's going to have a different shape. Y equals -3 over x. So again, the y is by itself. The only one that where I had to do any of that pre-work to get the number, to get the y by itself is that problem number 2. Other than that, everything's all y equals. So you can go straight to your calculator to y equals, clear it out, and type in what you need. So this time I need -3 divided by x. So -3. Then you're divided by, then your x is the denominator. Look at this graph. This is called a rational function. It has some graph up here and some graph up here. This problem actually is not going to want you to plot points. This shape is actually not over in the toolbox of shapes. You'll notice when you get to number 5 that it'll just be a multiple choice problem that you're matching to what's in your calculator. Okay, so the one that has graph up in the top left and bottom right would just be that one. That's what would match your calculator. So anytime it ends up with the x being in the denominator, is what gives it this shape. And those will be multiple choice if you run into that. All right, number 6. Y equals the absolute value of x minus 6. All right, so new shape. Something new is happening to the x. This one's an absolute value. The y is by itself, though. So just go to y equals, again, clear. Now, I need to type in those absolute value bars. Where you're going to find those is you're first going to hit this math button. Then you're going to come over here to number. So just hit the right arrow once to get over to number. And the very first thing under that is ABS, which stands for absolute value. So since my cursor is already on it, I'm just going to hit enter right now. So there's my absolute value bars. So now I just type what's inside those absolute value bars, which is that x minus 6. So x minus 6 inside there. If you want, since I'm OCD, I don't like my cursor staying in there, so I just move it out. It won't matter. And then you're going to graph. Now, here's the shape of absolute value. It's a V shape. Okay, here's the difference. Anytime you're graphing in MATLAB, for most shapes, it just says pick the shape and then start plotting points. That's what's going to be your instructions up here in the yellow rectangle when you're graphing, except for the V shape, the absolute value. It's going to make you plot the vertex first. And the vertex of that V shape is this point right here. So if you plot another point somewhere else, it's going to think that that's what you meant as the vertex, and it's going to make your V somewhere else. So when I'm looking at this graph, when I'm looking at this graph, I notice here's where my vertex is. So let's see, 1, 2, 3, 4, 5. It looks where my x is 6. And I notice when it's coming down, look where it's touching the x-axis there, which means the y there should be 0, right? Because the y being 0 is telling you what to not go up or down. So when I go to second table, I need to go down here to where the x is 6. So there's my 6, 0. That is going to be the vertex. That's where it came to the point. So it's gonna tell you that is what the point it's gonna want you to plot first. Just on this one problem, you're gonna do this. Once you plot that vertex, over at 6, 0, 1, 2, 3, 4, 5, 6, then your yellow rectangle up top is just going to say plot another point, which means now I can choose any of the other points. Okay, again, just like the U shape, the V is symmetrical, right? One side mirrors the other. So even though MATLAB is going to make me only plot one more point, I'm going to plot these two, right? The Y's being the same are what makes it mirror. So it's going to mirror at 5, 1 and 7, 1. So let's see, to the right, 1, 2, 3, 4, 5, up 1. And then to the right, 7 and up 1. That makes your V. All right, number 7. This is the last shape that we're going to see today. Y equals x to the 3rd plus 2. So this is a new shape because now the x is being cubed. Okay, once again, I just go to my y equals though. It's all the same steps. There's my y equals clear. There's my x. Now, unlike the x squared, it doesn't have its own special button like x squared does. So for any other exponents, to get your cursor up in the exponent, you do need to hit this up arrow thing. That puts me up in the exponent. Now just put whatever your exponent is, which is 3 in this case. Now remember, when you use that method, you're still up in the exponent. Okay, you don't want to be up in the exponent to type in that +2. So you need to hit the right arrow and then the +2. So let's see what this shape looks like. This is our last shape. I'll just call it a squiggle. This is what your graph is going to look like when you have an x to the 3rd graph. Okay, this will be, that shape will be over in your toolbox. You will have something that looks like that to choose from. This one, when you're graphing, it's going to make you plot 4 points. And in the middle of doing this graph, it's not going to look like it's going to end up shaping like this. It's going to look like a line, then it's going to look like a U shape, and it's going to look like something else. Once you plot that 4th point, it'll bring it all together. Okay. Another thing. So let's go to 2nd. Let's get some points. Now, look at these numbers. MATLAB's not going to let you plot those. So when you have to choose 4 of them. So you're going to choose these 4 right in here, right? Those are going to give you the points that are closest. So I'm just going to start with the -2, -6 points. -1, 1. 0, 2, and 1, 3. Okay, plot these 4 points. So -2, -6, which would mean to the left 2, down 6, -1, +1, which would mean to the left 1 and then up 1. Here's where the squiggle starts happening, 0, 2. So left and right 0, up 2. And then 1, 3. So to the right 1 and up 3. And again, once you hit that 4th point, it'll connect them to make that squiggle shape. It's going to be going crazy plotting these first 3 points. It's not going to look like it's graphing it right. All right, one more for this section, and then we'll move on to 2.2. Last one, and we've already done one like this. Y equals x squared minus 6. So y equals, clear it out. X squared minus 6. So x, and remember x squared does have its own button. You got to hit the x first and then that. The only thing that's nice about that is once you hit it, it comes back down to where you want to be instead of staying up in the exponent. So minus 6. Graph, it's an x squared, so this should make a u. So there's your u shape. Second table to get your points. And again, just because I like to see the mirroring, I'll choose, looks like, here's where the mirroring starts. So I'm going to choose these 3 points. So -1, -5, 0, -6. And then +1, -5. So -1, -5 means left 1 down 5. 0, -6. So my x is 0, so I don't go left or right at all. Since my y is -6, I'll go down 6. And then +1, -5. So to the right 1 and down 5. Oops, I missed it. And that'll make your parabola. Okay. All right, so that ends 2.1. I am also going to do 2.2 today because we're supposed to get through both of those sections today or this week, since y'all don't have class on Friday. All right, 2.2 is also going to be on functions and graphs. The first thing that we're going to talk about is what makes a correspondence a function or not. Okay, I'll give y'all a minute to write that down. All right. The definition of a function is a correspondence or a relationship where each element in the domain only corresponds to one element in the range. Your domain are your X values, your range are your Y values. Which means each X can only go to one Y. Now, let me show you on number 1. It's going to give you a domain. And it's going to give you a range. Your domain numbers are 10, 6, and 24. Your range numbers are 25 and 21. So this, and it also has these arrows. It says 10 goes to 25, which means that this element in the domain only went to one element in the range. The 6 goes to 21. So once again, this element in the domain only went to one element in the range. The 24's arrow also goes to 25. Here's where it gets kind of a little wonky. This element in the domain only goes to one element in the range, right? If there was going to be an element that went to more than one number in the range, you would see something that looked like this. 10 would have to go to 25 and 21. That's what would make it not a function, is if one of these numbers in the domain had 2 arrows coming out of it, but that is not the case. Each element in this domain only has 1 arrow coming out of it. If you've only got one, if you're only going to one thing, you are a function. So yes, this one is a function. All right. So we're going to use this definition to answer the next couple of problems. Number 2, the domain numbers are -1, 4, and 8. The range number is 2. -1 goes to 2, 4 goes to 2, and 8 goes to 2. But how many numbers does -1 go to? Just 1. How many numbers does 4 go to? Just 1. 8 only goes to 1. There is not any number in the domain that goes to multiple numbers in the range. So yes, this one is also a function because each element in the domain only corresponds to one number in the range. Number 3, same kind of thing. The domain is 64, 125, and 8. The range is -4, -5, -2. Okay, I kind of feel like a broken record here because 64 only got 1 arrow. 125, only 1 arrow. 8, only 1 arrow. So yes, that one is a function also. Number 4, the last one of these. All right, the domain. Now, instead of numbers, the domain is going to be two separate cities, Chicago and New York. The range is Bears, Bulls, Cubs. Knicks, Mets, Giants. Chicago goes to Bears, Bulls, Cubs. New York goes to Knicks, Mets, Giants. So now is where I'm seeing something different. This element in the domain, it's just Chicago now instead of a number, but this element in the domain is doing, how many elements in the range is it going to? 1, 2, 3. That's what makes you not a function. So that's why this is the one that is not a function. Because the elements in the domain went to multiple elements in the range. Okay. Now, the next handful of problems are going to give us a function and then ask us to evaluate what happens to that function depending on what number you're plugging in. We did this at the very beginning of class. Remember when we chose numbers to plug in for X before we knew how to tell the calculator to make our table for us? It's kind of what we're doing here. So number 6 gives us a function and it says K of X equals X plus 7. And it's going to ask us to find 1, 2, 3, 4, 5 things. The first thing it's going to ask me to find is what is K of 0. Here's the trick. Whatever is inside those parentheses, you put in that X and do the math. So it's saying, what would 0 do to this function right here? So I just put a 0 in there and see what it does. So if I put the 0 in place of the X, 0 plus 7 gives you 7. That's it. You're just replacing the X with whatever's in the parentheses. Whatever replaced X here, right? The X turned into a 0, so the X turned into a 0. It's going to ask you to do the same thing again. Now what is the X? It's negative 15. So again, I'm just plugging it in. Negative 15 plus 7. If you don't like doing this in your head, then by all means, that's what you got this calculator for. I just need, so if you're still in your y equals stuff, just hit second quit. That always gets you back to the home screen. So you would need to know what negative 15 plus 7 is. Remember, here's your negative button. So just type it in, negative 15 plus 7. Okay, so if you're not good with adding and subtracting with positives and negatives, punch that in, negative 8. Next one says, what's K of negative 4? So do you see what's happening? You're just replacing the X over and over and over again with whatever's in the parentheses, all in this same situation. So negative 4 plus 7. Again, if you don't like to do that, just punch it in. Negative 4 plus 7 is 3. Okay, a positive 15. Replacing the x this time with positive 15 plus 7 gives me 22. Now here's the last one. It's a little bit different. It says find k of x plus 18. So what have we been doing over and over and over and over? Whatever is in this parenthesis takes the place of this x. So what is going to take the place of this x this time? What's in the parentheses? X plus 18. So that replaces x. So I have x plus 18 is in replace of the x, and then add the 7, just like I've done over and over and over and over. Just instead of it just being a plain number, it's x plus 18. Now, when I've done that, now I can see who goes together. That 18 and 7 can be combined, right? Those are like terms. So now I still have the x. There was nothing to put with it, but it's still there. It doesn't just go away. And 18 plus 7 gives me 25. All right, number 6, same kind of problem. It's going to give us a function and ask us to evaluate it with different numbers. The function this time is, doesn't matter what the letters are up front. This one says h of w equals 9w plus 9. Whatever this is going to be the letter that's in your function. That's going to be the letter that you're going to just be replacing over and over with whatever's in the parentheses. So let's see. This first one says h of 1. So what did I do over and over? Where are you replacing? I'm putting this 1 in place of the w. So 9, since it's touching it, that means times 1 plus 9. So just replace the w with the 1 and then do the math. 9 times 1 is 9. Bring down my plus 9 to get 18. H of negative 8. Replacing the w with negative 8. So 9 times negative 8 plus 9. If you wanted to shorten this all the way, you can type exactly that in your calculator. It'll follow the order of operations for you. Just type in exactly what you see. So 9, open parentheses. What's inside the parentheses? Negative 8. So negative 8, close, plus 9. So exactly what I see there is what I put here. 9 times negative 8 plus 9. Enter. It'll follow the order of operations and do everything in the order it's supposed to be done. Negative 63. This one gives me a decimal. 6.7. I don't care though. I've got a calculator. I'm just going to do the same thing I did on that last one. 9 times, replacing w with 6.7 plus 9. I'm going to get your money's worth out of this calculator. So just like last time, 9, open parentheses. This time inside the parentheses, I have 6.7. So 6, here's my point down here below the 2. 0.7, close. After the parentheses, I have plus 9. hit enter. It follows the order of operations. It does everything in the correct way. 69.3. All right, number 7. F of x equals the absolute value of x, and then outside of that, minus 2. Okay, the only thing that's inside the absolute value is that x. The first thing it wants me to find is f of 2, which just means replace that x with a 2. So absolute value, replace the x with a 2, bring down the minus 2. When you're taking the absolute value of something, it's always going to come out positive. And here's the reason why. When you're taking the absolute value, you're saying how many spaces away from 0 is the number that's inside here. So whether you are a negative number or a positive number, you're a certain space. So even if you're negative 5, how many spaces away from 0 are you? You're 5 spaces away. Okay, positive 2 is 2 spaces away from 0. So the absolute value of 2 is 2. Bring down that minus 2. So that answer would be 0. The next one is f of 4. So replacing the x with 4. So the absolute value of 4 minus 2. The absolute value of 4 is 4. Bring down the minus 2, and 4 minus 2 is 2. Here's the only one that gets a little weird. F of a plus 2. So just like always, whatever is in here is what I'm replacing the x with. I don't care if it's the picture of a rainbow. If it's inside those parentheses, that's what you're replacing the x with. So if I'm replacing this x with a plus 2, I'll have absolute value. Instead of x in there, I'm going to have a plus 2 in there. Bring down the minus 2. This right here is as far as you can go with that. This is what you type in as your answer. Because of this a inside here, I can't bring anything out of that absolute value because I don't know what a is. I don't know what number it is. Okay, so that way I can't simplify this. So this right here is what you'll type in as your answer. And when you're typing in the absolute value, when you're in math lab, there's and you're typing in your answer box, down at the bottom of math lab, there's all kinds of different things. There's something that looks like this. So if you needed to type in an exponent, you'd have to hit that. It would go up in the exponent. There's also one that looks like this. If you hit this, it's going to give you the absolute value bars with an open box in the middle that you would put the a plus 2 in. Once you put that in, you would have to get your cursor out and then put the minus 2 out there. All right, on number 8, for sake of time, I'm only going to do part of it. It's just same stuff. The function is f of x equals x to the third. First thing I want you to find is f of 0. Just like always, go over here, wherever you see the x, put whatever's in the parentheses. So I have 0 to the third power. Well, 0 to the third, if you're raising something to the third power, that means to multiply it together 3 times. You can multiply it together however many times you want, but if that's a 0, doesn't matter, right? It's still going to be 0. Let's see, I'm going to skip a couple of part of these. It's got all the way through F. Okay, I'm going to do F of 3. Same thing, replace the X this time with the 3 to the 3rd power. This does not mean 3 times 3. It means to multiply 3 together 3 times. So 3 times 3 is 9 times 3 is 27. All right, replacing the X with -2. Here's where you need to be careful. So -2 to the 3rd power means -2 times -2 times -2, or punch it in your calculator, right? You can always punch stuff in your calculator. When you are raising numbers to an exponent, especially a negative number, you need to put parentheses around it just to get in that habit. So open parenthesis, -2, close. Now remember how to get up into your exponent. This little up arrow right here. And then type in your exponent. And hit enter. So -2 cubed gives me -8. And then I'm going to do the last one, because this one's the one that was throwing people off earlier. F of -3a. So once again, replacing whatever is in this parenthesis in place of the X. So I'm going to have, instead of X, I'm going to have -3a to the 3rd power. All of this is to the 3rd power. -3 is to the 3rd power, and so is a. So what does -3 to the 3rd power mean? It means -3 times -3, which is +9, times -3 again, which would be -27. So I've taken care of the -3. I've raised it to the 3rd power. Now I need to raise this a to the 3rd. Well, a to the 3rd is just that, a to the 3rd. So -27, a to the 3rd. All right, number 9. This is kind of a real world problem. It gives us the Fahrenheit temperature, how it corresponds to the Celsius temperature. So it's going to call it F of C. This is what they use. If somebody tells you what the temperature is in Celsius, that doesn't mean much to people that live in the United States, because we don't use Celsius, we use Fahrenheit. Okay, so if they say, so this says find the Fahrenheit temperature equivalent to 25 degrees Celsius. So in other words, we're going to find F of 25. We are finding what 25 would do if I put it in the Celsius spot. If it's 25 degrees Celsius, so let's replace this Celsius with 25. So we'll have 9/5 times 25 plus 32. Remember, calculators do fractions. So 9/5 times 20. I can type in that whole thing. 9/5, which would mean 9 divided by 5. Then what comes after that? Open parentheses, 25. Close. I can even add this to it. It'll follow the order of operations. If you tell it right what to do, it's going to do the right work. So 9/5 times 25 plus 32. Uh-oh. So 9/5 times 25 plus 32 gives you 77. So if it is 25 in Celsius, it is 77 in Fahrenheit. That's a good word. Okay. Now, I'm actually going to, so that was number 9. I'm going to skip 10, 11, 12, 13, and 14 for now, because we've actually already done it several times in 2.1. And I'll get to it in a minute, but when we are going to get to number 15, so I'm kind of jumping around here. So when you're doing your homework, it's going to skip some in the lecture, but we'll come back to it. Because if we don't get to all of those problems, you've already seen several of them in 2.1. All right, there is a simple way to determine whether a function or a correspondence is a function or not. Remember, we were doing this with domain and range at the beginning of this section. But what if they were just showing you the picture of the graph and saying, is this a function or not? That's when we could use what's called the vertical line test. All right, what the vertical line test says is if you can only touch the graph once with any vertical line, that's a vertical line, the one that goes straight up and down, then the graph is a function. So again, only touching the graph one time with the vertical line will make it a function. So we're going to use this rule to evaluate these last problems to see if they are functions or not. I'll give you a second to write that down. So 15 through the end is just going to give you a shape. Actually, I'm going to write them all up here at the same time. So it's better to see them together. So 15 looks like this. So these are the last 4 problems, 15, 16, 17, and 18. So we're going to use the vertical line test on each one to determine whether or not it's a function. Is there anywhere on this graph, this green shape right here, where I can draw a vertical line and touch it more than one time? If I draw a vertical line there, I can only touch it once. Once. There's nowhere on that graph where I would draw a vertical line and touch the green shape more than once. So yes, this one is a function. I can tell because it passes the vertical line test. What about this one though? If I draw a vertical line right here, it touches it right there and right there. That's what makes you not a function. to correlate that to the first problems that we would have had, this would have an element in your domain that went to more than one element in your range. That's what that corresponds to. Same thing here. Touches it once there, once there. Not a function. What about this one though? Only touches it once. Only touches it once. Only touches it once. There's not anywhere I can draw a vertical line on that shape and touch this up and down graph more than once. So that one is yes, that is a function. All right, I wanted to get those in because that was something that you hadn't seen before. Now I'm going to work number 10. And here's what I mean by you've seen several of these before in 2.1. Number 10 is going to say something like this. Graph the function f of x. So it's just going to say f of x equals, instead of y equals, the term f of x and y are interchangeable. Negative 2x plus 2. And then instead of you choosing any points you want, it's going to have you fill out this chart. But you can still, where do you get that chart? Your y equals. So you just go to your y equals. Because remember, this is the same thing as saying y equals. So go to y equals, clear it out, type in negative 2x plus 2. So negative 2x plus 2. Let's graph it. It should be a line, right? Nothing's happening to the x. So instead of, when I go to second table, instead of choosing any of those numbers, it wants me to choose specific ones. It wants to know what goes with the x being negative 2, what goes with the x being 0, and what goes with the x being positive 2. It's telling you what to choose out of your table. So let's see what goes with the x being negative 2. So there's where my x is negative 2. So you would just put the 6 in that spot. The next thing it wants to know is what goes with the x being 0. Well, there's what x, where's what x would be 0. You just put the 2 in that spot. And then the last one it wants to know is what's with the x being positive 2, negative 2. So that's all it's asking you to do on those middle problems that we're skipping. But we did a bunch of these in 2.1. After you fill out the chart, you'll plot 2 of those points. Okay, let me take roll real quick. And after I take roll, I'm going to stop this recording